फ्रैक्शंस लिखे थे। Still waiting.
Yeah, it's live now. Yeah, it's live. Yeah, I think. Can anyone check if everything is working fine? Then we shall start.
Yeah, I guess it's working fine now.
It's working fine now.
Yeah, so sound and video, everything is it fine on live? Okay. So let's start. So this is all about the data science and data analytics coursework that we are going to launch. And so hi, I am Archi Dash, and I'm the founder of Fractions, and I'm currently doing my PhD at Indian Statistical Institute, Kolkata. And so we at Fractions have come together to present you the course, the data science and data analytics workshop. And this event is organized to share with you more details on of our course. So we are starting our course from 15th February. There will be 3 classes per week, and the classes will be held from 9 p.m. to 11 p.m. So we'll start from the grassroots level, covering basics of each subjects we are teaching. So for this, we all we need is that you have maths, the basic maths, that is the 10+2 level. The curriculum is made keeping in mind the syllabus of undergrad statistics topics, which are very useful for data science. Now, so student from this science, tech, engineering, even mathematics and economics, so everyone can participate in this course and learn data science from the professionals. Now, we would be basically have 3 to 4 phases, and at the very end we will have the question section, where you'll be able to comment on the in the chat, and we will answer your questions. So coming to this, that let me first sketch the outline of this event in detail. So we begin with some common facts about our course and data science in general. During the discussion, we would meet the faculty members who are already present in this video. Next, we would discuss in detail the syllabus for each of the subjects. The next section would require more your involvement. In this, we would present some brain teasers and for you to engage in. So those will basically involve the questions that were asked in the interview of the top companies that your faculties are going to going for the jobs. So so let us now dive into the program, beginning with some facts and some discussion with the members, and then we will discuss some questions asked in the interviews, and finally we will end with a Q&A session for the audience. Now, so let's first start with Souhardya Ray. So, Souhardya, can you introduce yourself?
Yeah, so I'm Souhardya. Hi everyone. I did my bachelor's BStat from Indian Statistical Institute, and now I'm pursuing my MStat from the same institute, and I will join in Morgan Stanley as an associate in the upcoming summer. So that's from me. So let's discuss uh, why we are thinking of this course. So can I start?
Yeah, sure. Please.
Yeah. So my personal experience made me realize that why we should start this course for the upcoming students who have a dream to pursue a career in data science. Actually, all the mentors here felt the same at the different point in their life. So let me tell you my story. So during the internship hiring process in ISI in my MStat first year, so Hindustan Unilever was hiring from multiple campuses across the country, and I had an inclination towards marketing, so I applied for that. And after multiple rounds of screening and interview, I received an offer to join the prestigious ULI program in the sales and marketing stint, which is a very prestigious internship opportunity. So I readily accepted the offer. The preparation for Hindustan Unilever later helped me only in my HR interview. So I will add that later. So during the course of internship, I realized that I am more inclined towards data science oriented projects than marketing. So it is majorly because my training in statistics. After my internship tenure, I began the preparation for the final placements, and I had nearly no options for my final placements to pursue a marketing role. So my internship did not help me at all to crack investment banks or data science profile. In the beginning, I was really confused about which areas I should cover in that short time. So I revised the basics of statistics from my UG level class notes, but that was not at all enough for the placement system. So I started working on my data science skills, which includes machine learning, neural networks, data structure and algorithms. I had to skim through various online resources like the blogs, coding sites, lecture videos to gain a comparative knowledge on the relevant domains. I also invested a good amount of time to watch interviews of established people about how they prepared to be in their current position. I discussed some problems like puzzles and tricky probability questions with some of my friends. It was a kind of group study as a part of preparation. So there I learned to solve a problem in multiple ways when my interview will be. So all this helped me to secure a position in Morgan Stanley. Still, without guidance, it was somewhat an inefficient process. It would be much better if there was some guidance and a compact syllabus for it. At this point, I realized that there are not too many good and compact courses in the field of data science. And that is the primary motivation for us to begin this course so that we can help you. Thanks. Hope I'll see many of you in the classes.
Thank you, Souhardya. So, thanks for your sharing your experience and sharing the reason why people should join the data science course. So, now let's come to one of our other member, Archi. So, Archi did her B-Stat from ISI Kolkata, and now she's pursuing her M-Stat from the same institute. So, she will join Goldman Sachs as an analyst this year. So, yes, Archi, so can you introduce yourself and talk about your experience and what we will be providing in this course?
Yes, sure. So hello everyone, I'm Urchite. So I'm one of the faculty members here. So as Shuvardu said before me, so this is a vast syllabus, right? And You have a lot to catch up on. You have to prepare for a lot. You have to build your resume. There's a lot to do simply for. So if you are an aspiring data analyst and you are watching this, so the question in your mind is, what will I get? So that we got that question a lot. So for that, I have tried to uh, make up a precise view of what exactly we will be doing here. So Arkabruto, could you share the screen?
Yeah, sure.
Sure. So I decided to show you a mind map so you can see that how we are helping your journey.
Yeah, so this is the mind map.
Yeah. Is it visible on the screen?
Yes.
Okay.
Archie, could you
So
hold a second? I think it is not visible on the
Yeah, it's
YouTube
visible.
stream.
Yeah.
Perhaps it's now visible. You can
Yeah.
continue.
So
Sorry for the
yeah,
interruption.
it takes some time.
okay, sure. So what you can see in the mind map, first of all, you can see on the left side, you will see what are the basic courses that we have divided the whole structure into. And on the other side, you can see what are the steps you are basically following here. Um, so on here, you can see the linear algebra course, which will encompass your basic things that we are doing in the linear algebra structures. So you can see that here. And similarly, there are the probability theory course, the algorithm course, the statistics course, the neural network course. So this has all the subparts which will be followed thoroughly, and we will make sure that not only understanding, you need to implement it. So all of that details are will be covered, and also the faculty members will explain this part, the syllabus, intricately in the following discussion. So let me tell you about the other part that is on the right side. So the first step for you is you can build your resume. So how we are doing that? So you now, after this course, you will have an understanding of the basic data science tools. The latest tools are which all this always come up every time, and they keep on developing, and you need to be updated on those. So the interviewers, they will want to know what you know about all this. Similarly, again, the next step is using these tools, you want to plan projects. So these projects will what will fill your CV, and so you can say that not only I am going to work efficiently, I have worked on these things already. So that is our plan. And you can work with data here, and you can learn the basic languages in the steps. So the next step is, as one of the faculty members will follow, so you will have a detailed step-by-step view of the process which will go up to your selection in a company. So for that, you will have to give the tests. So the mock tests and the mock interviews, we aim to cover that thoroughly in the same pattern. So you already have an experience of what is going to happen in that whole process. So, and the third here is you have to enhance your problem solving skills. So you need to solve efficiently, and you need to solve it within the time span. So you would have to do all this collect problems, getting this tricky problems just from the internet. If you randomly go searching for it, it's not easy to practically find all those tricky problems. So we will combine that for you, and we will provide it to you, and we will have a lot of doubt clearing sessions for only for that. And finally, what we will do, all these resources we have, that is our lectures, and also these chunks of code we are going through in the implementation, that also will be provided to the attendants who will sign up for this course. Yeah, so that was the course schematics, and so I hope all of you who join this course, we will gain a lot from it. So that's all. Yeah, thank you.
Okay, yeah, thank you, Archi, for such a beautiful map and talking about the whole structure of the course. So now let's introduce Shayok. So Shayok, can you introduce yourself and
Hello everyone. I am Sayak Chatterjee. I am currently an master's student at the Indian Statistical Institute. I completed my BStat from 2017 to 2020, and my master's will be completed by 2022, I guess. And I will be talking about the procedure that one has to go for selection for, say, internships or, say, placements. And Orkoda, can you share the
Yeah,
mind map?
yeah, sure.
Okay. So is it visible?
Yeah, I think it's visible. So, would you like to talk about the stage 2 mind map?
Mind map 3, I guess, the procedure,
Okay.
right? This stage 2 mind map, right? So first, we have the aptitude tests. Uh, there are four major sections in this aptitude test. Basic mathematics MCQ. These are from the higher secondary syllabus, and you have to be accurate and efficient for solving these types of problems. Then we have some questions related to probability and statistics, where some conceptual problems are given in this section. And after that, we have some algorithmic MCQs, where you are provided, say, chunks of codes, and you have to provide what will be the output of that chunk of code. And then you have a coding section, competitive coding section, where within a given amount of time you have to design an algorithm for, say, two or three problems, and you have to uh, code basically. And the languages are generally in Python or C, I guess. And next, we have the interview rounds. There are more than one rounds of interviews, and generally in the first round, you are asked to introduce yourself, tell about yourself, and then there are some puzzle questions. These are particularly tricky problems, and you have to know the variety of the problems that are asked in the interviews. We will be providing those types of tricky questions in our coursework. We have designed the course in such a way that covers those things. And then we have some conceptual questions, again related to probability and statistics, and these are a bit more delicate than the MCQ problems, and you will be facing some theoretical problems as well, and, say, definitions, just testing your concepts on various fields of statistics and probability. And then there are some questions related to modeling and algorithm, where you will be given a hypothetical situation where you have to again design an algorithm, and, say, within a specific time complexity, an efficient algorithm to perform a certain kind of task. Actually, and the second rounds of interviews, they ask actually about the previous projects you have done. So you will be submitting your CV. So they will go through your CV and ask about the past projects that you have carried out. And there will be they will also ask some data science tools, starting from simple linear regression to up to, say, neural networks. Then there will be some group discussions on a variety of topics, and there will be some case study also. That depends on the company that is hiring. So, for example, there are companies, there are insurance companies where given some amount of data about the customer, you have to you have to predict or say how much premium you can expect from that particular customer. Problems like that. So these are basically the types of questions that are asked in the interview. Then you have some HR questions, and if you have any question about the company, you can ask. That is generally kept at the last part. So all the interviews are consists mainly of these parts, but for each interview, all the parts may not be present. This is basically the union, I can say. So, so more or less, this is the selection procedure that one has to go through for internships or placements. So that's all from me.
Okay, yeah. Thanks, Shag. So, I hope the concise presentation clarified a lot about hiring, and I would emphasize here that our platform provides the students a number of mock tests and as well as mock interviews and aptitudes to gauge their progress. So, next we shed some light on where we would land after cracking these interviews. So the boom of data science jobs in present times has been phenomenal. I would like Anis to underscore this topic. So yes, Anis, could you come up and introduce yourself and enlighten us?
Hello everyone. I am Anis here. I'm one of the faculty members at Fractions, and I am also, like my other friends, a student of final year MStat, and I will be at my BStat from ISI itself. And the coming year, I will be joining Morgan Chase as an associate. So, as Shayak nicely explained, the interview hiring procedures and the aptitude and the rigorous training which everyone has to go through, which every one of us here present has gone through, and one question that we commonly face after this is that what kind of jobs are available in the market after going through this procedure, and there is such a hype created of the data science, and where all people land up. So it is like nothing new for you all to know that today is the world of data. Like data is the fuel of today's economy, and in fact, one of the estimates show that by 2025, the volume of data is going to be like 180 zettabytes. Zettabyte is around 10 power 21 bytes, so that's a very huge number. And this voluminous data that will require domain experts who can convert it into actionable insights through advanced technology. Hence, this role of data scientists is fundamental and is nowhere going to deplete in coming times. That data scientists need to be armed with the knowledge of subjects like statistics, mathematics, and computer programming. And data scientists leverage this power of technology to gain insights from the data businesses. A short presentation I have made on this topic. Autuda, can you please share the screen?
Sure.
It is just highlighting how the trend of data science jobs has increased over the years.
Yeah, let me just share the. Yeah, so you can share.
Just go to the page below.
Yeah, it's done already. So.
Okay. So there is a lag in.
Right. There's a lag there.
Okay. So as I was highlighting, you can see from the figure that this demand of data science has been overall increasing across the years. And this figure is, by the way, captured from Analytics Magazine of India. It is one of the leading startups in Bangalore, which provides amazing insights about the analytic industry. I suggest you check them out too from time to time. So this World Economic Forum that reports that by 2022, this job is going to be the highest, and the growth for this data scientist job is going to be one of the highest demanding jobs. And this survey is this similar results are given by many independent surveys too. Now that this data scientist is a broad term, Orkut, could you go to next slide, please?
Yeah, sure.
It comprises different terms. For example, there are jobs when you say a data scientist is comprised of terms like data analyst, data scientists, and data engineers. There is very little difference between these different kinds of jobs that people take up, depending on what kind of skills are required for each one of them. So, right, so it's here now. So though the work that you will be taking up after joining the company, that depends on what kind of work is assigned to you. Broadly, their classification is as follows: data analysts. Data analysts are people who are primarily interested in processing of data, and regular analysis method is done by them. And one of their main jobs is performing this primary analysis and communicating the results to the superior managers. Another term is data engineer. So as the name suggests, their main role is building the data infrastructure. They are more focused on extracting, transforming, and putting data than data analysis and data scientists. So if you can see from the figure below, please scroll down a bit.
Yeah, that's the done.
So apart from data engineering, there are roles of data scientists and quantitative analysts. So data engineering, as I was referring to, that concerns more of building the infrastructure. So they are more interested in the data wrangling part, or the data software engineering part. If you can see from the orange spider chart, as it's called, it's one of the amazing representation tools which in data visualization techniques. So this data engineer is more inclined towards the data wrangling and data infrastructure and software engineering part than the statistics part. On the other hand, if you see a term like data scientists, so data scientists are people who are more inclined, the green one, the statistics part and the advanced mathematics part. So their inclined is more towards, say, the statistics and the theoretical part, and somewhere in between lies the data analyst. Apart from this, there are one more term called the quantitative analysts, which are nothing but data scientists who are involved in business solutions, in financial markets. So data scientists who are involved in financial markets, those can be termed as a quantitative analysts, or the QA, as they are commonly called. The next slide, I present some skills which are demanded for almost every of these jobs. Please.
Yeah, I scrolled down, so it should show up.
So the skills are mainly, as also evident from the chart, that statistics, programming, and machine learning. Right, it's here. Statistics, programming, machine learning, and linear algebra and calculus. So these are very pivotal towards gaining a strong foundation to gain a job in any of these fields. Apart from this, we have some more required skills like DSA and ML, which gives us newer and structured solutions to business problems. So more or less, this is the usual job profile and the skills demanded. And as you can see that most of the skills are statistics and programming, machine learning and linear algebra, which are in our course structure. It will be presented next in our next phase in the deal syllabus of this. Thank you.
Okay, thank you, Anis. So that was all about the job market scenario, and now let's go to the third phase, the syllabus schematics. So uh, let's discuss the syllabus that we are going to cover. So let's go to the course page. So the topics we will discuss in the course are broadly divided into 5 categories, and which will be presented one by one. So Anis, can you start with the statistics part?
Sure. I'm not. I'm audible, right?
Yeah, you are. So let me scroll down
okay.
to the.
Thank you for that. Just a second. Right. So I will be covering the statistics part, and now I don't need to emphasize that how important statistics is for the data science, as the word itself, data science, is the science or knowledge of data, which statistics is all about. So we know how important statistics is, right? But where to start, what topics to dig into, and up to what level? If time and energy are not a constraint, then ideally we would pick we would pick a textbook for each topic and finish it off from start to end, like we used to do in earlier days. But it would take years if we go in that way, and that approach, it would be better if someone were to explain what the relevant topics were. This is where we lie. We are handpicked the most relevant topics, and we are not just explaining the topics through videos, but also testing you through assignments and quizzes. Thereby, we bridge the gap between the rigor which is present in textbooks and the lucidity and easiness of the videos. And the topics which we have mentioned here, like how have we picked up this topic? This statistics is vast. Like there are numerous branches to it which have active research going on. Some sections of statisticians are involved in developing methodologies which are better than existing ones, or proving the desirable properties like consistencies of existing models. Our purpose to learn statistics, however, is primarily for data science. In our course, our end aim would be to understand the nuts and bolts of commonly used models, rather than viewing these models as a black box. We want to be able to answer questions like how a result would change if we were to run a particular algorithm on a certain tweak version of the data. So this way, we rather want to dig deeper into the model itself. And with this end goal in mind, it is mandatory to lay strong foundations. So let us dive into what we will be covering in this course. So first of all comes the descriptive statistics part. So this is concerned with summarization or description of the characteristics of data set. Descriptive statistics primarily consists of two categories. Descriptive statistics basically consists of two categories: measure of central tendency and measure of variability. We would learn about different data types and their summarization tools. Next up is estimation. Estimation is primarily as follows: like when a sample is drawn from a population with a known form but some unknown parameter, say theta, we want to estimate that parameter. And how do we estimate parameter? Well, we'll be discussing questions like this. Discuss MLE methods, the EM algorithm. At the same time, under this section, we have questions like how do we compare which estimator is better than the other? For example, and another one of the question is how does confidence interval mean in sense of true value of the like what does the real meaning of the word confidence interval? Next up is hypothesis testing. Hypothesis testing is basically as follows: that we make a statement about unknown parameter. The problem is to judge whether the hypothesis, whether we accept it or reject it in light of data. So there are two kinds of errors: the type 1 error as type 2 error, which some of you might know. Which error is more better, which is more bad, that we will discuss. We will see why a p-value is frowned upon by a section of statisticians. We would learn about likelihood ratio test, which would help in construction of test statistics. Next up is fitting probability distributions, which should mark the end of level 1. In fitting probability distributions, this is more or less clear by the name itself, that we draw a sample and we try, if we do not know the form which it follows, we just check how the different distributions are fitting. We discuss the Pearson's goodness of fit test and the Kolmogorov-Smirnov test. This is widely used in the industry. The next one is linear regression. So linear regression is the basic tool which every one of us use till now, and perhaps every data scientist is the first armory in every data scientist arsenal. So it provides a striking balance between the interpretability and accuracy. There is more to it than drawing least square minimizing line. We would discuss how the regression line emerges as the MLE when the errors are taken to be normally distributed. Besides, we also discuss the least absolute declaration, that is when the error metric is taken to be absolute error instead of square error, how the nature of things change. The next important point is linear models. At the same time, I would like to highlight here that we have marked some problem solving sessions, which will cover the topics taught till then. Coming back to linear models, that this is perhaps the most important from the job perspective. We begin with general Gauss-Markov setup and discuss ways of testing significance of predictors. This will give rise to ANOVA, and we will discuss some estimability issues. Next, we will discuss some model diagnostics, what happens when some assumptions are not met, or how the performance of Gaussian model is sometimes unreliable. Next up comes the resampling techniques. This is, say, an add-on to any of the models that you will try, because in resampling techniques, we learn about cross-validation, we learn about jackknife and bootstrap, and we compare this in different procedures in what method, in what kind of data types we should be using, what type of method, or in what case the estimate scored by a jackknife is better than a bootstrap estimate, and so on. Further up is an important topic, generalized least square. So generalized least square, we talk about the general setup of that. There is a link function, and there is a basically there is a model for deviance of that, and how do we estimate a general linear model, and how we see that how a linear regression or a linear model is just a simple case of generalized least squares. We discuss other types of regression in there, like logistic regression and Poisson regression. We see that each of this emerges out as a special case of the generalized linear model. So from that perspective, this is a pretty broad topic, and this is wise to conclude our level 2 by that topic. Further up is penalized regression. So this is perhaps a topic you have come across many a times in blogs and internets and textbooks like that. So penalized regression is when we use a penalty that the coefficients do not grow up very large. So different methods of penalized regression are like lasso regression, or the ridge, or the elastic net, which is a combination of lasso and ridge, and how this can be incorporated in different methods. Further up is the categorical data analysis. In categorical data, we basically discuss in details the contingency tables and the probability structure. Then there is the odds ratio, which we will be talking about, and how to measure independence of two variables or two categorical variables. And to conclude, there are two topics: regression techniques. And regression techniques is pretty important because we will be summarizing everything you need to know about things when things go wrong. Basically, how when a general linear model fails, how what kind of imputations you need to make things work, or different methods and so on, and how to compare two models. We will discuss like Mallow CP and the AIC and the PIC criteria. Final up is the time series, which is itself very important, and we discuss about the autoregressive models and the autoregressive models with how to test with exogenous variables and so on and so forth. I think that marks an end to our syllabus, and just I would like to highlight that there will be numerous quizzes and mock tests, and as highlighted in the circles up there, which we will continuously evaluate.
Okay.
So thank you for this. That's mostly the course was going to be about.
Okay. Thank you, Anis, for such a detailed review of the stat syllabus. So next, I would like to introduce you all to Diganta Bhattacharya. So, Diganta, can you introduce yourself? So,
Yeah, am I audible?
yeah, let me just.
Yeah. So let me introduce myself. I'm Diganta. I'm pursuing MStat from Indian Statistical Institute, Kolkata. So, like my friends, I have also completed my BStat from my side. I've been teaching in fractions for a bit now. I've been doing some other courses that you can check out on the website and also on the YouTube link. So in this course, is it being shared? Yeah, I guess.
Yeah, so would you like me to share the syllabus?
Yeah.
Okay,
Please.
so let's go to the syllabus.
Yeah. So the syllabus is uploaded on the website, and there are many other mock materials and other mock tests and other stuff that you can find on the website. So
Yeah, here is the linear algebra syllabus.
yeah, it's visible, right? So
Right.
let's start. So we'll start off with like there's a demo note on the website. You can check. So we have started off with the two-dimensional plane, that is R2. So we'll talk about the concepts in R2 first because we are mostly familiar with the XY plane, right? Then we'll move on to system of linear equations and the main motivation behind this subject, like linear algebra and linear models, where they come from and how does they help us. So then we'll move on to some the vector spaces and projections. So what we'll learn there is basically how the shapes behave, and then in order to work with those shapes, we need to define some inner products and orthogonal projections also. Like what do I mean by perpendicularity there, and what do I mean by angles there, and other stuff. So then we move on to matrix decompositions. So we would be introducing matrix by then. So then we would need some decompositions of matrices in order to do some stuff that you will see in statistics, and we'll also do you will also see why we need the factorizations, like the decompositions, later on when we start learning about eigenvalues and eigenvectors. Now there are several topics like vector calculus and vector algebra. Inside that, we'll have to learn a bit about how the calculus works in case of matrices and vectors. Then there's linear regression. So you will be learning that in statistics also. So I'll be giving you an idea about linear regression from this point of view. Then we'll go to dimensionality reduction with PCA that you have mostly seen in most of the projects that you have seen online or in a Kaggle notebook. So what's the mathematics behind it and how do we do it? Then we come on to Gaussian mixture models. Then a very important topic, that is kernel density estimation. So After all of this is done, we'll do some high dimensional, we'll check some high dimensional data and we'll apply some support vector machines there, right? And during the whole course, we'll have model implementations in R and Python. So you'll have the codes and the notebooks in order to go through that, go through the whole syllabus, right? I guess that's all.
Okay, yeah. Thanks, Diganta, for the detailed review of the linear algebra syllabus. So, now let's go to Sayak. So, Sayak, uh, would you like to discuss
Hello.
the algo and data structure syllabus?
Yeah, sure. Please share the course
Yeah,
map.
yeah,
Hmm.
it's sure.
Okay. So, as I discussed earlier, the data structure and algorithm course, this is one of the most important courses which is needed for the selection procedure for internships and jobs. So, we will emphasize a lot on this topic, data structures and algorithms. We will first start with introduction and analysis of algorithms. Uh, we will talk about different types of algorithms. Then we will move to find and search algorithms, different searching algorithms, and how to search in different data structures efficiently. And we will also talk about the time complexities of each algorithms. Then we will move on to say sorting algorithms like quick sort, heap sort, sorting algorithms like that, and parallelly, we will be talking about data structures. Like for heap sort, we have to know about the data structure heap, right? So we will be talking about data structures parallelly with the corresponding algorithms. Then comes the data structure topic. There will be talking about heaps, binary trees, linked lists, and such data structures, stack, queue, heap, and such things. That marks the end of level 1. And after that, we will be talking about search trees and hashing, say binary search trees, or some search trees where there are more than two children, which are not necessarily binary, but search trees. Then we will be moving on to algorithms involving sequence and sets. These are very important uh, for the competitive coding section. We will be talking about, say, uh, recurrence relations, divide and conquer algorithms, dynamic programming, and such things. Then we will be moving on to graph algorithms, where we will be discussing algorithms like Kruskal or Dijkstra's algorithm. Then we'll be moving on, say, minimum spanning tree. This is also one of the graph algorithms. Actually, this marks the end of level 2. Then we will be also discussing some advanced topics like single source shortest paths in graphs, max flow algorithms, max flow mean cut theorem. We will be talking about that. Then we will be also talking about some geometric algorithms, uh, which are very, very important. We will be talking about that. For say maximization and minimization problems, we will be discussing about Newton-Raphson algorithms, gradient descent algorithms like that. And finally, we will be ending our course with NP completeness. This is a pretty advanced topic, and we will be needing some prerequisites which will be covering throughout the course. And throughout the course, we will be having 3 problem solving sessions, 2 mock tests, 2 doubt clearing sessions, and 2 mock viva. So hope you guys enjoy this course a lot. So that's from me.
Okay, thank you, Sayak. So, okay, let's next come to the probability section. So, probability is one of the most fundamental topics which you'll be learning in this course. And so, Archi, can you please go into the detail of this course?
Yes, sure. So I think all of you have done some basic probability in your high school, and you remember some bits of it, of course. And also in today's articles, newspapers, everywhere, you are seeing these terms that chances and probabilities, this percentages. So all of that is supporting the whole concepts of statistics and regression and everything which had been discussed in before. All of the statistics, you need to understand the basics firstly to understand what is happening with all the hypothesis testing and the model fittings there. And also you need to have a good grip of how to solve problems in probability itself to get through the interviews, right? I need to, so what we would do, we would give you a concise idea of the basics and also discuss some advanced ways so you can quickly solve all the problems. So, firstly, you will begin with the classical probability, which some of it is covered in high school, and we will extend that. Then we will define these random variables. Firstly, there will be the discrete variables, which will have some values, mostly integer values or something. And then we can have these continuous random variables, this distributions you regularly hear of, say the Gaussian distribution, all this probability distributions. We will learn the relationships, the transformations between these distributions, and how to work with these distributions efficiently, their expectations, and on all of this there will be extensive problem solving. So, and you have to understand some basic inequalities that hold for this probability theory, which will be discussed here. And finally, we will have some modes of convergence, which is specifically for the random variables. So that will complete our level 1. And you will have some vivas and tests here, so you have a good grip of what is going on. And then we will again discuss some convergence theorems, that is the strong law of numbers, the weak law, and the convergence to Gaussian distributions. These are very important when we are working with large data, because you need to understand that what do we really mean by large, and we are approximating a lot when we do this testing. So are these approximations valid? You need to understand that, and that is where the convergence theorems come in. And then, of course, if you're going from real to you're working with many variables, you need to understand random vectors. So you say you have a data and you have many features of that data. So you no longer have only one real value, you have several values. So you need to understand how different variables work together. So you will see their joint distributions, which will be covered in this random vectors part. So for everything that is covered in this probability theory, there is a real life equivalent of that we will see in statistics. And you will work on this, implement that in the statistics, and in probability, you have to understand the theory behind those models. And then you'll get to some stochastic processes, which is basically you will look at some collections of random variables which are changing, say, over time. And as time series was discussed, the probability equivalent of that is stochastic processes. And it is very important if you apply to companies which have data that changes with time, say banks, say this life insurance companies. Every company nowadays have data that are incoming with time, and to deal with that, you need to not know only things about one variable, but about variables that are changing with time. So that is what will be covered here. And so this has parts 1 and 2. So you can learn about various of the common models in stochastic processes, like you will go through Markov processes, the Poisson process, the simple random walks, etc. And you can learn about, at the end you can think about which type of data will fit where, and you can deal with the properties of these processes, that what follows for each process. So you have a better grip there. And finally, this will end your level 2. and now you want to look into some further basic understanding. So you want to look into some measure theory stuff, which will be covered here. And of course, we will not make this like too theoretic or too monotonous, and we'll make sure that the intuition is uh, conveyed through these lectures. And so it will be kept simple, but also to a level in which you can directly work with problems from here, which is the initial aim for us. And finally, we will have this conditional probability, which is again a very important topic, I would say, for us for the interviews. Like all of us who have given these interviews, more or less, uh, all of us have faced somewhere questions on conditional probability. And finally, we will do some more interesting topics like martingale theory to show you that very strong results exist, which can be directly applied to everything we are doing and the questions you are facing. So you can not only give one solution, maybe you can give two solutions by the end of this course to one problem by different methods applied from this. Yeah. So that will be an overview of this course, and there will be many problem sheets in here for each section, so that you can get a thorough understanding and you really build your problem solving skills on this part. So yeah, that will be all for this course.
I guess the audio is.
Okay, so yeah, sorry for the audio. So yes, thank you, Archi, for the nice description of the probability part of the course. And so the remaining part is machine learning and neural networks. So which will be covered by Ranojoy Dutta. So Ranojoy,
Yes, hi.
yeah.
Yeah, so hi everyone. This is Ranojoy. I am one of the mentors of the ML and the neural nets course. Now I'm going to give you a quick glimpse of what the course is going to look like. So nowadays, you know that machine learning has become one of the most demanded skill for data science roles. And we all know that machine learning basically automates the process of data analysis and then makes data informed predictions in real time without any human intervention. Our data model is built automatically and further trained to make real time predictions. So basically, the course is incomplete without visiting ML formally, right? So, but there again, we know the domain is vast. There are many things that are being designed and published day after day. So we had to carefully choose the course, what topics we need to teach. Like all the previously mentioned course, we primarily have 12 lectures in the ML and neural nets. The course has been well curated to keep a balance between theory and application. Uh, as you can see that first we're going to understand the basic jargons of ML, learn exploratory data analysis, and then move to learn core concepts like classification, regression, dimensionality reduction, especially PCA, TSNE, and clustering like k-means and dbScan. So both supervised and unsupervised algorithms are going to be taught thoroughly. The statistics course that's also been offered out here is going to cover a good theoretical proportion of these topics. And so we are going to have coding sessions to see the applications of these topics. There will be extensive assignments and exams to help you measure your progress. The second part has been made to focus on programming ML-based systems. We would build recommendation systems, random forest-based models, spam filter, etc. And finally, we would look at the neural networks and the key architectures of deep learning. That's all we have planned for this course, and I strongly believe that you will enjoy the course. Thank you.
Okay, thank you, Ranja. So now we'll go to our next phase, which you have been waiting for. Our phase 4 consists of all the interview questions that you that we all faced in the interview. So the interview questions will be discussed. So let's Okay, so let's start with Diganto. So Diganto, can you share your interview questions and experience?
Yeah, sure. So uh, the one that I remember on top of my head was this. I was asked this once, like, say there are two stations, suppose A and B, and there's a station in between, suppose C. So the orientation is like this: A, C, then B. So A, C, B. So now one train comes from A to B and another train comes from B to A. So they both start their journey at 5 p.m., suppose, and they end the journey at 6 p.m. So one train is coming from A to B, going from in between 5 to 6, and the other train is going from B to A, 5 to 6, same time. So the question asked was, there's a station in between, C, right? So both of those trains stop in that station C for 5 minutes. So there's a person who is in the first train, which is going from A to B. He wants to step down in the station C and then go and catch the other train, right? So he wants to go back to A, essentially. So he stops at C and then tries to swap the train, right? So the trains, both the trains, arrive at the point C uniformly in between these time points, 5 and 6 p.m. So what is the probability that this person will be able to swap the trains and go back to A, starting from A? So this was the question that was asked. So you can think, you can actually figure this out if you write down the probabilities. So it would be something like you essentially have to calculate an area, right? So but if you don't visualize it like an area, so it would be very difficult for you to calculate verbally. So like this can be calculated verbally, right? How you see that this 5 to 6, this is basically a block, right? So this is a square block of essentially, say I divide it into 60 minutes. So 60 by 60 block, right? So in this 60 by 60 block, what I need to do is that if I am that person, I need to stay inside a particular shape. So what does that shape look like? That shape looks like cutting off two triangles from a square. So the thing inside looks like a something like a square with two triangles on the end, a rectangle with two triangles on the end, right? So now how do you find the area for that? So essentially it's the whole square's area minus the area of the smaller square, which is found by the upper triangle and the lower triangle, right? So essentially what you do is you take out 5, like the unit 5, because that's the time it's taking to stop at the point C. So you cut 5 lengths of 5 from the from origin to the x-axis, origin to the y-axis, and similarly on the top of the square. So you get two triangles with smaller sides, add them up, you get a square. So subtract this area from the bigger square. So that's the probability, right? So you can calculate this out, and this is a pretty interesting problem, right? So this was one of the questions that I faced, and one pretty trick HR question was like this. One of my friends faced this. So it was like fill up the blanks, and it was like blank T, F blank S. Okay, so I'll repeat once: blank T, F blank S. So I won't spoil the fun for this one, but do check out our schedule on the website. You can get a hint from that. Yeah. So, Archi?
Yes, so I have an interesting problem to share as well. So consider this. There's a random number generator and it's giving you real numbers, and this generator is from a continuous distribution. That means you can assume that if you get two numbers from here, so the chances that they will be equal is 0. And also if I take one number from this generator and then again it is giving you a second number, these two will be completely independent. There's no dependence among these numbers. So you are doing this. At first, you are getting a number. You take that number. Next, the generator gives you another number. If you are getting a bigger number than the first one, you keep the number. Otherwise, you stop it and you say, I have got one number. Again, if the second number, if you can keep the second number, then again you take a third number. If it is even bigger, you can add it to your list, or you have to stop and say that I have two numbers. So you are repeating this process as long as it goes. And so at finally you will say that I have some numbers in my list. This number of real numbers are in my list. So the question I was asked is, so can you tell me what is the expected length of my list that I will have in the end? So this is an interesting question. And the tricky part here is, as you noticed, I haven't told you anything about the generator, right? So what happened there? So why is not that relevant? So what you can do, firstly, you think about it like this. Uh, we have it's seeming like we have to consider infinite sequences, that's making it complex. But see, if you take, say, 5 numbers, you know what is the probability that all of this will be in perfect increasing sequence, which is just one possibility among all the 5 factorial possibilities, right? So if we gather that, so for again among 2, we will have the probability is 1 by 2 factorial. Among 3, we will have the probability is 1 by 3 factorial, and so on. And as you know, the expectation that will be the sum of these probabilities. So what you do to get the answer, you add up this, that is 1 plus 1 by 2 factorial plus 1 by 3 factorial, and so on. And you know that this expansion is E, so that will be your answer. E minus 1, so that will be your answer. So that it is E minus 1 because it's in starting we have 1 in the initials. Yeah, so that was an interesting question I faced.
Okay, thank you, Urchi, for sharing your interview questions. So I hope there were more questions, so those will be discussed in the course. But now let's go to Souhardya. So can you share your some of the interview questions?
Yeah, I'll share one of my interview question I faced. So that is a pretty basic question. The question was X and Y that follows normal 0, 1, both follows jointly, and they have a correlation rho. So what will be the correlation of X square comma Y square? The thing is, the some of the students from stat background, they can spontaneously answer that it is a rho square. But the thing is, it was asked in interview, not in aptitude test, like an MCQ question. That was not that. So I was asked in interview, and I had to prove it in the interview. So the thing is, you need 4 concepts mainly to solve this problem. The first is a very basic. You need to know the definitions of correlation, covariance, and variance. So the first thing, you have to write the correlation formula, which is the covariance of x square comma y square divided by root over variance of x into variance of root over variance of y. So to calculate the variance of x square and variance of y square in this case, because we are calculating x square and y square, the correlation of x square and y square, for that you have to calculate it in this way: expectation of x to the power 4 minus expectation of x square whole square. So for expectation of x to the power 4, you need to know the fourth order moment of a normal 0, 1, and you have to write 3 there. So that will save your time during interview. That is the second thing you need to know. The most interesting thing is coming after that. So in the other part, I mean, expectation of the definition of covariance, expectation of x square y square minus expectation of x square into expectation of y square. In the covariance of x square comma y square part, their expectation of x square and expectation of y square, you can write it easily. But for expectation of x square into y square, for that part, you have to know 2 concepts. The first is the double expectation. For double expectation, the thing is expectation of x square comma x square y square. You can write it as expectation of x square y square given x. And for that given x part, you can split. You can just take out the x square from the expression. So the next line will be expectation of x square into expectation of y square given x. So now within the first expectation, I mean within the bracket, the expectation, there is no x square part, just y square given x part. So for there, the fourth concept is coming. The fourth concept is you have to know the conditional distribution of y given x. So from the conditional expectation, the conditional distribution of y given x, you are getting the expectation and the variance of y given x. So for the expectation of y square given x, you are getting it from variance of y given x minus a plus expectation of y given x whole square. So from there, you are getting that result and using it here. And after all the calculations, you will get the expectation of x square comma y square given x is nothing but expectation of x square into 1 minus rho square plus rho square into x to the power 4. From there, again, you need the fourth order moment of normal 0, 1. And there you are using 3 there. So the final result will be 1 minus rho square plus 3 rho square. So when you put it in the first expression of correlation, you will get a 2 rho square above and a root 2 into root 2 in the denominator. So ultimately, you will get rho square after cancelling out the constant parts. So that was a ready, and you have a ready answer for that. But to prove it, you need some deep statistical and probabilistic knowledge. So I faced it. Hope you'll enjoy. Yeah.
Oh, thanks, Souhardya. That was pretty tough question, I should say, but glad that you did it and you did it during the interview, and that's what basically landed you the job you have. So that's pretty great. Like, I have a question which I faced that was actually on a lighter end, but it's tricky to think that it's only a small trick part, and I'm sure like some of you might have definitely faced this question. So the question goes as follows: that there are two trains, one moving from this direction on the same line. They are moving in opposite direction on the same line. Say one of them has the speed u and the other has the speed v, and they're moving towards each other. There is a fly which starts from one train and moves continuously with a constant speed, say with the speed flies with the speed f from one train windshield to the other train windshield. As soon as it touches the other train's windshield, it just switches direction instantaneously. We do not take any time loss there, and continues to move with a velocity with a speed f towards the opposite direction. And once again, it is here. It switches direction and moves to the opposite side. So this goes on continuously until the two trains are coming closer and they collide. The question is simple, like what is the distance traveled by the fly? Now, if we see the number of, if we try to go it into the approach of taking the number, like each time we calculate what is the time, like if each time we calculate the speed, the distance between the train and the speed distance covered by the spider in each round, going that way makes it very lengthy and perhaps incomputable, since infinite number of rounds are involved, of course. So easier way to do this is to look at from the frame of reference of one of the train. So or just to calculate the time taken for the train to collide, and that is simply the initial distance b divided by u plus b. So this is the time taken for the flies to for the like this is the time taken for the train to collide, and this is the time with which during which the flies fly with the constant speed f. Hence the answer should be d by u plus b times f. So there's the only trick to observe is that not look at rounds rather than look at the entire motion together. So that was easy, but just a small note has to observation had to be made. Uh,
Okay, yeah. Thank you, Anis.
Thank you,
So,
Anis. It was a pretty interesting problem. And I also have a tricky problem to discuss with you guys. Suppose you have two random variables, say x and y, which are, say, not necessarily independent. Can you construct examples of such x and y such that each of them will have infinite expectations? However, the minimum of those two random variables will have a finite expectation. Just think about it for a moment. This is tricky because a key idea that will be used to construct an example is like this. Suppose you have a real number x and you look at 1 by x. Okay. Now you look at the minimum of x and 1 by x. Observe that it won't cross 1. It won't go above 1. Suppose, for example, let us take x and y to be non-negative. Okay. Then the minimum of x and 1 by x, if we take x to be non-negative, the minimum of x and 1 by x will be between 0 and 1. So it will be a bounded thing. And as we know, the expectation of a bounded random variable is always finite. So now our task is to construct such random variables so that x and 1 by x both has infinite expectation. Now, how can we do that? Suppose, let us take the example of, say, Cauchy distribution. We can visualize the Cauchy distribution as a ratio of two standard normal distributions, say u and v. The distribution, suppose u and v follows normal 0, 1, then this is a standard result that u by v follows Cauchy distribution. Then observe that if we take reciprocal of that, v by u, that will also follow Cauchy distribution, because again v and u are two independent normal distributions. So you have two distributions. So you have two random variables which are reciprocals of one another, having the same Cauchy distribution. But the problem is Cauchy distribution does not have an expectation. So what we can do, we can restrict it to the non-negative real line part. So we can just take modulus of that. Okay. So just take u and v following normal 0, 1, and take x to be modulus of u by v and y to be modulus of v by u. Then the minimum of x comma y will be bounded between 0 and 1, and hence will have a finite expectation. But you can easily check that the expectation of x and y both will be infinite. So this was one of the tricky problems that I faced. It was really good to discuss it with you guys. Hope you enjoyed it. Thanks.
okay, thank you, Sayak. Thank you all for sharing your experience and interview questions. So we would like to now go into the Q&A section. So has anyone any question? So you can comment down in the chat box. Yeah, so if no one has any questions, so then we'll wrap it up here. So the first class, that is on 15th, will be taken by Sayak Chatterjee, and the second class on 18th will be taken by Ridhiman Shaha, and yeah, so the rest of the schedule has been posted in the website, so you can follow up from there. So yeah, if so no one has any question, so okay, then let's end it here then.